Hey folks, I am going to show how to use one of these Sparkfun Facet RTK GNSS receivers to collect data for post-processing. Not real-time kinematic, but post-processing. And what that lets you do is you can collect your data in the field and then you can apply corrections after the fact. When you're back in your office or your house or your classroom or whatever. And so the things you need are one of these Sparkfun facets. You need a micro SD card in the card slot. You need the settings to be set up correctly. And the easiest way to do that is just by using my settings file, which I'm linking below in the description. And what you need is for the SD card to get a log of all of the data coming into the antennas on this unit. And that's what you need to post-process rather than just your coordinates. You need the actual raw data coming in from all of the GPS, GLONASS, etc. satellites. The other thing you need is a log from a base station. And that can be your own base station, but I'm going to show how to use the log from NOAA, Continuously Operating Reference Station Network. And the other thing you need is software. You need something like RTK lib, but I use Emlid Studio, which is based on that open source system. And it's made by the Emlid company, which makes their own units. And I saw a post on the Sparkfun forum, and there was someone who knew about the software but thought it was restricted to Emlid hardware, but it'll work with any U-Blocks based receivers. So this really applies not only to these, but any that uses the U-Blocks chip and creates a UBX file or a Rhinex file. So really probably every type of unit. There may be some that create proprietary files. I'm not sure. But if you have a Rhinex or a UBX file as your log, you can use the Emlid Studio program. So that is what the text file with all of your settings looks like, and that just goes on your micro SD card. And if you put in a blank SD card, it'll generate one of these files with its settings that it has set. And if you put in an SD card with different settings, it'll load those settings. So measurement rate, and that's in milliseconds. And that's how many times a second basically you'll get a measurement. So like if you have a Garmin GPS unit, like the ones you use for hiking, the little handhelds, those will typically log at 1 point per second. As I said, you need the log, but you also need a start and an end time. So what you can do is you can take this, you can turn it on, leave it on for your entire trip out in the field collecting ground control points. Or you can put it on a point, turn it on, so it starts logging, and then when you go back to grab it after several hours or a day or however long, you turn it off and it'll stop logging. But when you're using just the unit like this without a tripod, it's pretty easy to shift it. When you're grabbing it, it's easy to like block the signal, and that is going to mess with your readings. So what I like to do is put it down, turn it on, and then take 2 photos. One photo when I know it's in place, one photo when I know it's secure in place in the right position, and then a second photo when I go back to grab it. And so that gives you a period of time where you know you're getting good readings without it moving around or without you over it blocking the GPS signals. and it gives you something that you can go back to in the future and have an easy reference, because I always forget. As soon as I do something, I forget what I did. And so I really need that as a way to go back. In Lightroom, when you press I, you get all of your metadata, like your location data. See, it shows the GPS, your coordinates, and the start time. And so that is important. That start time is when I can start my processing. And you'll see what this actually means when I go through the process. But I put my start time in that text file just as a note. And then my photo, when I went back to grab it, would have been, let's see, that one, which was 7:41:43. So I put both of those into Notepad, 7:41:43. So I have my start time and my end time. And then another picture I like to take is without anything on it. So after I remove it, I take that picture just to know, okay, after that point, I removed it. You need to actually grab the UBX files from your SD card. So I already did that. I don't think I need to show how to drag and drop, but you just drag and drop into some place where you can keep track. And so I have a folder on pCloud, so it's easy to access from any computer, and I just put in my date and location, real general. So here's what is important. Okay, so I've got the UBX files and my settings file, just because I like to copy everything from the SD card. So those are copied to my folder with the date and the time right here. So this is the relevant one. So I'm going to make another folder for my files that I don't need, just so they're out of the way and I don't get confused. So that's my UBX file that I'm concerned with. And it starts UTC time, midnight and 26 minutes. And so what I'm going to do is go to the NOAA CORS site. And the easy way to find this is Google NOAA CORS user friendly, and then it should be the first link. And so I need to put in my start date, which is going to be May, actually, because it's UTC time. So again, look at this, 2025 05 04. So that's UTC time. So I was collecting on the 3rd, but in UTC it was already, which is in, it's kind of the same as Greenwich Meridian time almost. Not exactly the same, but pretty much the time in England is when your date would be. So I just need to choose my start time and the number of hours. And so UTC time would have been 00 midnight and 20 something minutes. So I just need to put in that 00 and then my UTC time zone. And then my duration, I only need 1 hour, so I'm going to choose 1 hour, but you would choose however many you need. And you might need to like piece these together if you have a log longer than a day. So 1 hour, and then I need to choose my site. So this is important. You need to have a site, a reference station that is close to where you actually did your work, as close as possible. So I'm going to open the CORS map in a new tab. All the disclaimer stuff, hit OK. And these are all the reference stations all around the world. Well, it's mostly in the US. So I'm going to zoom into my area, which is Central Texas. And you can see all of these on the map. The closest one looks like the SAM 2 because I was in this area somewhere, and that's not too far. The other ones are much further. I'm kind of surprised we don't have more of these stations. Like, really, there should be multiple in Austin. It's a big city. There's one in Bastrop. But yeah, this SAM2, Surveying and Mapping LLC, and a lot of these are run by private companies. And it's operational, it says. It's not, out of commission or anything. And there's all this information you can look at. So I'm going to go back, and on my pick a site, it has every site listed. So I'm going to hit S, and that takes me to the S's, and I can choose SAM1. Leave this as is, and it looks like there's no data. It should have data because it's been over half a day, and it's one of those ones that updates pretty often. So this is not good. So I'm going to go back here, and I'm going to choose a different site. There's one in San Marcos. There's one way out here. Let's see. I'm going to choose this TXJC. So let's see if I go to T, TXGC. Okay, this is not showing unavailable or anything. So I'm going to choose all the signals, and I'm going to choose coordinate file and IGS orbits. I'm not sure if you need those. I think you do, because it gives you information about the correction data, and then I think the orbit information should be on the log file on this anyway, but I like to choose those. And NGS, I've had issues where I select that and that causes the download to not work, so I just leave it unchecked. And then hit the get cores data file, and then it starts to download. And so that is actually downloaded. I'm going to open the file, and then I'm just going to drag and drop into my same folder. Drag and drop, drag and drop. So it's there. Just to keep organized, you can also put it into a subfolder. Rename my... So drag those files into that subfolder, and then they're all together. So once you have that, you can actually do the correction. So I'm going to open Emlid, or I should already have it running. Yes. So there's Emlid Studio, and we're going to do static processing because we're grabbed with the unit in one place, a control point. If you had it mounted to your car for mapping like a road or something, you would use kinematic. And there's some other options like drone, stop and go. If you're using the Emlid software, you would use the stop and go, or you can just convert to Rhinex. So I'm going to do static, and I'm going to choose the receiver file. I'm going to choose the static receiver file, which is just the UBX file. So I'm going to go back to my Facet folder, and then my May 3rd, and then I can choose that UBX. And the first thing it does is convert to Rhinex. But we're not worried about the slight difference between those. We just need to know the rough height between the base where it was on the concrete to where the antenna is, right? And so it tells you on the unit. You probably can't see that on my little webcam, but let's see. Okay, so antenna height, very important. And if you use a tripod, like I said, you need to know the height of the tripod, but you also need to know the height of the antenna within this unit, because it was on the concrete pad, but then the antenna is inside of this. So it's not just the position of your antenna you're calculating. There has to be an offset. And it's printed really tiny, 57.4. So I'm going to actually put that in my notepad. There's two antennas. One of them is 57.4 millimeter, and the other one is 61.4 millimeter. So, like, what's the average of those? I mean, I can do the math, but let me just 57.4 plus 61.4, and you divide that by 2. So the average between those two antennas, the offset, is 59.4. And I kind of don't like weird numbers like that, so I'm just going to pretend it's 60 millimeters. So I'm going to type in 59.4, but then I'm going to round it up to 60 millimeters. Because we're not really worried about a fraction, a tiny little fraction of a millimeter. That's way less than our actual precision and accuracy anyway. So I'm just going to put in use antenna height, yes, and then 0.06 meter. So that is set. And if you had a tripod, you would measure your actual height of your tripod or your pole or whatever you're using to offset, and you would have to put that as well. You would add it to your 59.4. Now I'm going to choose the base. So I hit that, and then in my subfolder txjc, I'm going to choose that 25O observation file. And it loads some metadata about the position of the station. And you can't edit stuff, but you shouldn't edit this. This is what it is. It's the antenna. You don't need to figure out an offset to this. You would if you're using your own base station, but this has everything you need here. So I'm going to hit this gear, and there are some important settings in here. So the first one is the time period. So that's what I got from my photos. So 7/27/19. So I'm just going to round up a bit and put in 7:28 p.m. as my start time, which would be UTC would be 00:28. Okay. And then my end time, I'm going to actually have that be a little bit before. So I'm basically rounding inward, if that makes sense. So I'm going to have that be 0:41. So I just need to put in 28 and then 41. So it's originally it had the length of the entire log, and I just narrowed it down to my time period when I know it was on that spot. Okay, so what we want is the one best point, but I'm going to first look at all solutions because I want to see what it actually looks like. And that'll make sense when I actually run it and you see the image. This drop down, I always set it to combine because it seems to provide a better result. Elevation mask, so that it's kind of an important setting if you're in a place with a lot of trees or buildings or anything like that, because you can mask out things below that angle. So a 15-degree angle is about like that. So if you've got trees that are within that line of sight, then you're good because you're filtering out that 15 degrees. the atmosphere also messes with the signals. So that 15 degree will get rid of the signals that are going through a lot of atmosphere. So 15 degree, I usually leave that as the default unless there really is a lot of stuff around. And you can also go back and look at your image, of course, and see, okay, what were the conditions like? You know, if you're doing a lot of points, it helps to have the image again. So, you know, it's pretty open place. There's nothing within that 15 degree except one shrub off to one side, but it's not going to block the signal a lot, so I'm not even worried about it. So 15 degree, I'm going to leave that as default. And then all these checked except the IR and SS, because I think that's only in India. And I think the Beidou is only in China, but I'm just going to leave it. I don't think it'll cause any harm to have it checked. So those are those settings, and then your other ones are, again, for the type of correction you're doing. And I'm not sure why this is duplicated in so many places, because we're already in static, right? But we also have to choose this. So if you're doing a GPS log of a roadway or something, you would do continuous, or like a hiking trail, you would use that. This is just 1 point, fix and hold. Same for GLONASS, fix and hold. BDS on. Next setting, solution format, lat, long, and height. That's what I always get, because this is for GIS and photogrammetry and stuff like that. Time format should be UTC. There is something called GPS time, which is offset a little bit because time is drifting for those GPS satellites because they're moving really fast and they have lower gravity. So it's like a theory of relativity thing where GPS time is not the same as UTC time. It's off by like 19 seconds or something. So make sure you choose UTC. It's going to be useful if you have anything you need to align with that GPS data. So not so much for this, but if you're collecting like a virtual tour or something like that, and you're using one of these units as your GPS, then it becomes very important to have everything line up. Or if you're using a drone, your drone photos need to be in the same time frame as your GPS data. So just always have this set to UTC unless you have some reason not to. Latitude, longitude format. You can have degrees, minutes, and seconds, which to me is kind of old-timey. It's like from the days of like sailors and their instruments and stuff like that. For most things, we want to use decimal degrees because that makes it way easier. It's one number, one decimal number. It's not degrees, minutes, and seconds. It's just one number. So that makes things easier. And debug, leave off. Then you hit save. Then process. That is actually really good. See that? All of my points for that 13-minute time period are basically a couple millimeters apart. Now, technically, that doesn't tell you how accurate it is, but it gives you a good idea. If you have a nice tight cluster, that means your unit had good signal and there wasn't, factors that decrease accuracy too much. So to me, like subjectively, that says I have good data. You also get this indicator where it tells you whether you're fixed or float. And I don't quite understand the meaning of those terms as far as the math. There's a lot of math behind all of this. But basically, if you have a fix, that means you have probably good accurate positioning. And 100% of my readings here are fixed. which is a surprise to me because when I used that SAM-1 base station before for the same concrete pad for about an hour, I don't think I had any fix points. It was all float. So maybe this particular base station is just better. I don't know, but so this is the result, the actual log, and every single one of those readings. Remember, it's 4 every second, so that's a ton of readings, and they're in a nice tight cluster. And again, that doesn't tell you technically your accuracy, but it helps to know, like, if they're scattered everywhere and you have like a wide range, if they fall within like a whole meter or 10 feet or something, then you kind of know it can't really be that accurate. And then you're relying more on the averaging to get those averaged down to one location. But I'm pretty happy with this. So I'm going to hit the gear again, and I'm going to switch to one best, hit save, and hit process again. And I get my 1 point. So you can click that, and it gives you the coordinates and the height in meters. So you can just use that. And you can put this into your photogrammetry software, your GIS software, whatever it may be. But there's another really important thing. So I don't want to skip over this because it's really very important. Those coordinates are not just coordinates. They're coordinates that go with a certain coordinate system and geoid. And that is extremely important. So what I'm going to do is go back to my folder where I have those TXJC base station files downloaded. And there is here a README file and there's a log file. So I'm hoping one of those tells me what coordinate system that base station is assuming. And one thing to be very careful of is that Emlid Studio assumes everything is WGS 84. And there's a lot to it. There's a lot of math and there's a lot of theory behind how this correction process actually works. It is not just like an offset that you are figuring out. There's a lot to it because this is based on the actual signals. And what is happening is you are taking your log from your base station and your log from your rover and your log from the base station off in, west of here, way west, according to that NOAA map. And you know the location of that station and you know what those readings from the satellite should be. Because that's a fixed, surveyed, super high precision location. But you also know what the actual signal is like. And you're basically applying a correction, an offset to every one of those beams coming in from all those satellites. And those corrections are getting applied to the data from your rover. And I may have spent too much time just explaining that, but that's important to understand because it means that there's a lot to it that a lot of people who are even in the surveying field and the GIS field don't really understand. And I think it's important to understand these things because then you know why certain things are important. So the coordinate system of that base station is very important. And Emlid Studio is assuming WGS 84, and it's not. And really, it should know exactly where that station is. But the way it works out is that it's assuming WGS84. It gives you an output in WGS84, but it's not WGS84, and it's probably NAD83. So let's see this file, Johnson City, and it tells you, can I zoom in on this? So that's my coordinate. But I can go to the folder, and I've got some data in here. There's new files, so I'm going to sort by date, and the last one, that .pos file, should be, if I open it in Notepad, yes, so that has your output, and then 7129. So there's a little bit of rounding, probably not enough to matter, but I like to use the most accurate output that I can. So I like to grab it from this file along with the height. And so it has this 172.1493. Very precise, probably too much precision. It also, let's see. So it tells you in here, your coordinates are in lat, long, and height in WGS84, ellipsoidal. So that WGS84 part is false. And the reason it's false is because Emlid Studio is assuming that your base station is in WGS84. Those coordinates that it showed right here, that lat long for that base station way out in Johnson City, Texas, it assumes WGS84, but they're not WGS84, and I'll show you how you can know that. So you go to your folder where you downloaded your files. So I had made this TXJC, and then there's this coordinate file. So let me actually open this in Notepad so I can zoom in, edit in Notepad. Okay, so there's my Johnson City cores. And it shows you the coordinate system. So it's NAD83 2011. So that is the actual coordinate system. So there's actually an offset from the very beginning, or an error, when you do your processing, because Emlid Studio is assuming WGS84 when those coordinates are in a different system that is, it could be like a meter off. So that's a source of error right there. But the way this all works, and I kind of don't want to get too much into this, but you have this base station out in Johnson City. Let's just, for a visual, let's say this little gizmo is the base station. Your signals are coming in from space, from all these satellites, hitting that base station antenna. And those are coded signals, so it's like a sequence of numbers. And because that base station is extremely precisely surveyed, you know what that signal is supposed to be at any given time. Like, let's say it's a sequence of numbers, 1, 2, 3, 4, 5. At 3 seconds, it has to be a 3. At 4 seconds, it has to be a 4. And so on. But there's error from the signal going through the atmosphere, the ionosphere, all kinds of stuff. Even moisture can affect those signals, so they get slowed down. So at your point in time where it should be a 3, you might get a 4, you might get a 5. And because you know the position of that base station, and you know what you should be getting, you can then use that to create an offset. So you can say, okay, so the signal from GPS satellite 23 is off by 2 seconds. It's being delayed by 2 seconds. So when your unit in the field is collecting that log, that's why you need that entire log. Not like your Garmin where it estimates its location and then gives you coordinates. You need the actual log, because then you can apply a correction to all those signals that it's receiving. And so it might not be all the same satellites, but you have that log from that base station in Johnson City, and you apply those same corrections using the software or I mean, not the same corrections, but you apply corrections based on the position of that base station. So that's why you need to know the position of that base station. But we have this error here where it's assuming the wrong position because it thinks it's WGS84, but that ends up not mattering because it all evens out in the end. So we get this output that Emlid Studio says is in WGS84. All we have to do is say no. We know it's in NAD 83 2011, or we know the base station is in NAD 83 2011. So we're just going to assume the output is in NAD 83 2011, and that ends up being close enough where that's all you have to do is just make the opposite assumption, basically. So you're taking this offset error that the software did, and you're basically going the other way, the opposite way, and that ends up being close enough that we are good with that. So we've got these coordinates in NAD 83 2011. And in my case, I use Agisoft Metashape Pro, and I'm working with drone photos that have coordinates that are in WGS84. So the coordinate system I use for my projects is WGS84 because it's the easiest. And that means we need to actually convert from NAD 83 2011 to WGS84. Now the problem is there's not really an easy way to do that I've found. There are several websites that can do conversions, but I haven't found one that actually works and takes NAD 83 2011 and gives you WGS 84. And so the only way I know of is to use GIS software, and I use ArcGIS Pro. It may be possible to do it with QGIS, but I haven't tried. But in ArcGIS Pro and probably every GIS software, what you're doing is you're creating points with these coordinates. You're telling the software that they're in NAD 83 2011, and then you can use conversions like exporting to a new file that is WGS 84, and that should give you the correct coordinates. Or you can do like a calculation, stuff like that. So let me show how to do it in ArcGIS Pro. I think probably most people doing this kind of thing have GIS software, so hopefully it's not too big an obstacle. But so the first thing in once you have your project in ArcGIS Pro is to set your coordinate system, and it needs to be that NAD 83 2011. And if you need a let's see, okay, right click details, there's a WKID, and that's the code for that coordinate system. So that's super important because if you're doing any kind of conversion, you probably have to reference that. Now WGS 84 is going to be 4326 is the code for WGS 84. So if you find some kind of script or something that can do your conversion, those are probably what you're going to use as your reference codes. So my project has to be NAD 83 2011. And then what I'm going to do is use the XY tool. Let's see. So that's under map. So you need to go to the map ribbon, go to XY, and then you take your coordinates. So my X is going to be that longitude. Control C. Paste that in. Latitude, Control C. Paste that in. Make sure it's decimal degrees, and then I'm going to hit flash location. So yeah, that's the right location. Make sure you don't mix up your latitude and longitude. Now I'm going to hit, let's see, choose from my drop down. I'm going to choose this one, That puts down a point, a pin, and then the XY coordinate. And then I'm going to click that. And there it is. I can now zoom in. So that's my coordinate. Used to be underwater, see? Now if I choose my satellite photo, you can see it's all dry now. Wow, that's actually really accurate. Huh. So that's the concrete block, and so that's within a meter. So that means that satellite photo is really, really good, really accurate. So that's good to know. So this is just a graphic. This is not GIS data, right? So I need to actually convert this. And you can do things like save as a layer file or a layer package. I don't think that creates actual GIS data. But you know what? Let me try. If I do save as layer file, what does that do? No, layer X. No, I mean you can create layer. You can create other kinds of layer data, but not actual GIS. So what I need to do is create a real feature class. So I need to go to Analysis Tools, and then one of the many tools you have access to in ArcGIS Pro, create feature class. Okay, so I'm going to hit create feature class. And I'm just going to create it in my project geodatabase because this is just a temporary format. So I'm going to call it GCP's demo, and I'm going to make it point. And my coordinate system has to be same as the map. And this is extremely important. It needs to match, otherwise you're going to get small errors. If you choose WGS84 as your coordinate system for this, things are not going to be exactly as they should be. So for now, we're sticking with that NAD 83 2011. And I'm going to hit run, create, which creates that feature class and adds it to the map. So there it is. I can close this now. And I can double click on this and choose a different symbol. So I'm going to choose a triangle and close that. Now I can actually create my point. And so I still have this pin here. So I'm going to go to Edit, Tab, or Edit Ribbon, Create, and then it lets me choose my layer on here. So I click that, and then it lets me place it, and it'll snap to that. If I zoom in, it's easier to see. You can.
It's 3 o'clock.
So you can move. You can put your point anywhere, but it's going to snap to that. There it is. Now hit save, and that's in your feature class. Now you can right-click, open the attribute table, and there's no attributes. So we need to actually create attributes so that we can use this, right? So I'm going to create one that is called name, and that's just going to be text, and it's going to be 64 characters long. And I'm going to create another one that is X, and that is going to be a double, which is basically like a real number, so you get a decimal. And a Y, same thing. And then elevation, I'm going to just call it meters. And so I've got my name, X, Y, and meters, and I'm going to hit save. Now, why did I create the X and the Y? So the name is obvious, right? Concrete block center at Lakeway City Park. So that lets me know what it is that I'm referring to. X and the Y. Oh, and then the meters is going to be the height. So let me just put that in right now before I forget. Copy this. So that has my meters, and then I can hit save. So my X and Y, though, I'm not going to type those in. I need to actually calculate those. And I'm going to right click and do calculate geometry. And then, so it's letting me choose X, and then I'm going to have that be point X coordinate. But the coordinate format is going to be, I need to make sure it's decimal degrees. And the coordinate system is not going to be N8083. Hit the globe, and then you have to put in WGS84. So let me search. It's not turning up, but if I do, let's see, what did I say the code was? 43626? Is that right? I don't remember now. Yes. So WGS84 shows up when I type in 4326, and I'm actually going to add this to my favorites. I thought it already was in my favorites, but okay, so 4326, WGS84 pops up, select it, just add it to your favorites to make it easier, hit OK, and then I could just do this calculation, but I'm going to choose the Y and put in Y coordinates. And there are some things you can choose, like you can choose an output coordinate system and the geographic transformation, but by default it'll choose these. So you can leave these blank, and I'm going to hit OK. And now we have an actual output. So your X and your Y here, zoomed in, very different, or not very different, but they are different numbers. That one's 64487, this one's 64495. This one's 3378195, this one's 378201. So that's the same location on the Earth, but with two different XY coordinates because it's two different coordinate systems. And now that is ready to put into Agisoft Metashape or whatever program, assuming you're using WGS84. So I'm going to hit save, make sure these values are saved. Now, that's basically ready. That's your coordinates, and then you need to know the N8083. So just to be thorough, I'm going to create another field here. Doesn't have to be super long. Let's say WGS84. So then I know these coordinates are in WGS84. Now remember, the actual feature class is still N8083. So the source of this shows you the spatial reference, and that is N8083. It's just those fields in the table that we calculated as WGS84. So that's why I put this in here, so I know that these numbers are WGS84. Hopefully that makes sense.